Okay, I wanted to share something. It's not really a trick. I've just seen a lot of people struggle when like our notebook slides are small like this, especially in those Chromebooks, they're really small. So you see this little magnifying glass? Click on it and don't do the drop down. Just click on it and then draw a square over the area that you want to zoom in on, and it'll zoom in on that specific area. Because I hate when I just zoom into 100% and then it's like too big and it's not really the right fit. So you can just draw a square on the area you want to zoom in on. While I'm zoomed in on this area, I want to talk about it because not everyone came on Zoom and heard me explain this. And this periodic table right here is really important. So you need to know that group one is super reactive. They are the most reactive. And group 17. Those two groups are the most reactive, not group 7, because that would be right here, group 17. And I'm going to tell you why in a second. But all these other groups that are orange, these ones are reactive. They'll react. They will, but they're not crazy reactive. Remember the video you saw with all the elements in group 1? You just put them in water and they react. So these two are the most reactive. And then we have this group over here that's stable. Stable means does not react. The reason, or they are stable because they have 8 valence electrons in their shell, in their outermost energy level. 8 is the most valence electrons an element can have. So if they have 8, they're full. That group is called the noble gases. I didn't give them that name. That's just the name. But I'm like, okay, so they're full. They have everything they need. They have all 8 valence electrons, and they're called the noble gases. Noble makes me think of like royalty, like kings and queens. So they're noble, they're royal. Okay, so then I start to think maybe they're snobby because they have everything they need. Okay, so they don't mess with anyone else. They already have all 8, so they don't have a reason to talk to any other element because they have everything they need. So they say to themselves, having 8 valence electrons, that's the goal. So they are goals. But group 17, how many more do they need? How many more valence electrons did they need to be stable? Just 1. That's why they're going crazy. They're so reactive. If they can get 1 more valence electron, then they are stable. And same thing with group 1. If they can give away 1 valence electron, then they are stable. So these two groups are the most reactive because they are 1 away from being stable. So 17 is the most reactive, and then the reactivity decreases as the elements would have to do more work to become stable. So like 16, they need 2 valence electrons to become stable, so they're less reactive. 15, they need 3, so they're less reactive. 14, they need 4, so they're even less reactive. But when you get to 13, they have 3. They can give 3 away. So 13 is more reactive than 14 because 14 has more work to do. They have to get 4 valence electrons. Okay, so that is how you zoom. And that is reactivity, which will be on your test on Tuesday.